The Channel Tunnel is one of the greatest feats of engineering ever achieved. This 50-kilometer-long railway tunnel sits beneath the English Channel at a depth of around 75 meters. It allows trains to travel between the United Kingdom and France without ever seeing daylight. So how exactly did engineers manage to build such an impressive structure? What kind of technology was used to bring their vision to reality? Join us as we explore the mind-blowing engineering behind the Channel Tunnel. One of the biggest challenges for high-speed trains is the resistance created by the compressed air in front of the train as it moves through a tunnel. While this might seem like a small inconvenience, the pressure from the air can be so strong that it can completely stop a moving train. As the train approaches the end of a tunnel, the air has nowhere to go except forward. Thus, the air in front of the train gets compressed, creating a wall of air that the train must push through. This effect becomes more pronounced with increasing speed. So as the train accelerates, the air resistance increases exponentially. If the train's engine cannot overcome this resistance, it will simply be pushed back. To combat this problem, engineers came up with the idea of compressing the air ahead of the train by building a chamber at the end of the tunnel. By doing so, the air in front of the train is no longer compressed when the train approaches the end of the tunnel, since it's already been compressed into a smaller space. However, this solution comes with its own set of problems. Since the air in the chamber is now less dense than the air outside the chamber, there will be a net flow of air from the chamber to the outside world through any openings. This means that if the opening is not properly sealed, there will be a constant stream of air flowing out of the tunnel, which is obviously not ideal. To prevent this, engineers had to develop a system of bellows that could expand and contract to regulate the flow of air. This system consisted of a series of flexible chambers that were attached to the sides of the tunnel, which could be inflated or deflated to increase or decrease the pressure in the tunnel. Another issue that needed to be addressed was the need for maintenance access. It would be impractical and dangerous to send workers into the main tunnel to carry out repairs or maintenance work. To solve this problem, engineers built a series of smaller service tunnels and cross passages that connected the two main tunnels. These tunnels allowed workers to safely enter the main tunnel and carry out any necessary work. These are just some of the many challenges that engineers had to overcome to make the Channel Tunnel a reality. Their ingenuity and hard work allowed them to create a structure that has become a marvel of modern engineering. The first step in building the Channel Tunnel was to excavate the earth using one of two main methods, the cut and cover method or the trench method. Once the land had been cleared, the next step was to lay the foundation for the tunnel. This was done by driving piles into the ground and then pouring concrete around them. The piles were necessary to stabilize the tunnel and prevent it from collapsing. Next, the tunnel itself was constructed by digging a trench and then laying concrete segments along the bottom. These segments were then filled with soil to create a hollow chamber. This process was repeated until the entire tunnel had been constructed. In order to ensure that the two halves of the tunnel met in the middle, engineers used a technique called tunneling with a template. This involved drilling two separate tunnels using tunnel boring machines, TB-MIS, and then connecting them together using a series of prefabricated segments. The TB-MIS were guided by a template that ensured they stayed on the correct path and would eventually converge in the middle. However, the actual construction of the tunnel was only possible after several years of intensive research and development. Engineers had to find new and innovative ways to overcome the challenges posed by the unique environment of the English Channel. One of the most significant developments was the invention of a new type of tunnel boring machine, TBM, capable of digging through the chalk layer that runs beneath the seabed. The previous TBMs were designed to dig through harder materials such as rock and clay, but they weren't suitable for digging through chalk. The new TBMs had to be stronger and more stable to prevent them from collapsing in on themselves as they dug through the soft, crumbly chalk. Another major challenge was ensuring that the two tunnels being dug by the TBMs would intersect at the correct angle. If the tunnels didn't meet at the right angle, the entire project would have to be abandoned and started over. To solve this problem, engineers developed a new surveying technique called laser scanning. Laser scanning involves using a laser to measure distances with great accuracy. By using this technique, engineers were able to map out the exact path that each TBM needed to take to ensure that they met in the middle. But even with these advancements, there was still the problem of how to keep the TB-MIS on the correct path. The TB-MIS were massive machines weighing over 1,000 tons, and they were constantly pushing forward with great force. Any deviation from the planned path could have catastrophic consequences. To solve this problem, engineers came up with the idea of using a series of sensors and gyroscopes to keep the TB-MiS on track. These sensors would detect any movement of the machine and send signals to the operator to correct the course. But even with all of these technological advancements, the construction of the Chunnel tunnel was still an incredibly risky undertaking. There were numerous close calls during the construction process and several accidents that could have derailed the entire project. For example, in 1988, one of the TBMs broke through the floor of the shaft that it was digging. This could have caused the entire shaft to collapse and bury the TBM under tons of concrete. But thanks to the quick reactions of the engineers, the disaster was averted and the TBM was successfully recovered. But despite all of the challenges and setbacks, the Chunnel tunnel was eventually completed in 1989. The feat of engineering and construction was a triumph of human ingenuity and perseverance, and today it stands as a testament to what can be achieved when people set their minds to it. What's your favorite thing about the Chunnel tunnel? Let us know in the comments below. Also, check out our other videos and make sure to subscribe so you won't miss out on future content. We'd really appreciate it if you could give us a thumbs up for more amazing videos. Thanks for watching.